Herrenknecht Tunnel Boring Machine. A Herrenknecht tunnel boring machine costs between $50 and $60 million, and every single one is built once, for one project, and never used again. It is a bespoke subterranean factory, designed around the specific geology, hydrostatic pressure, and soil composition of a single tunnel. The machine rotates a cutter head fitted with hardened disc cutters that grind through rock, clay, or sand. Hydraulic jacks push the entire assembly forward while excavated material travels backward on a conveyor. Robotic arms simultaneously install precast concrete segments in rings behind the cutting face, building the permanent tunnel wall in real time. A single unit can exceed 17 meters in diameter. When multiple units were deployed for the Channel Tunnel, they bored from both England and France simultaneously and met beneath the seabed with millimeter precision. At the end of many projects, recovering the machine costs more than leaving it. Several units have been steered off their bore path and encased permanently in concrete. $60 million objects absorbed into the infrastructure they created. Bagger 293. The Bagger 293 is the largest land vehicle ever built by mass. Manufactured by Tachraf in 1995 for the Hambach open-pit coal mine in western Germany, it weighs 14,200 metric tons, stretches 225 meters end to end, stands 96 meters tall, and cost approximately $100 million. At its front end rotates a wheel 21 meters in diameter, fitted with 18 buckets each holding 15 cubic meters of material. The wheel turns continuously, feeding a conveyor belt running the length of the machine. On a full operational day, the Bagger 293 excavates 240,000 cubic meters of earth, equivalent to 96 Olympic swimming pools. It requires a crew of 5. Despite its mass, 12 crawler tracks distribute its weight so evenly that its ground pressure is comparable to a person walking across soft soil. When it needs to relocate between mine sectors, roads must be reinforced, high-voltage power lines temporarily removed, and the process takes weeks to cover distances a person walks in minutes. ASML TwinScan EXE 5000. The ASML TwinScan EXE 5000 costs $400 million, weighs 150 metric tons, and manufactures computer chips by projecting light at a wavelength of 13.5 nanometers, so short that it is absorbed by almost every material it contacts, including air. The machine's optical path operates in a vacuum, using mirrors ground to a surface accuracy measured in fractions of a nanometer rather than lenses, which would absorb the light entirely. Installing a single unit requires 250 shipping crates, 250 engineers, and 6 months of calibration. Its resolution of 8 nanometers allows chipmakers to print transistor features smaller than any previous generation of equipment, enabling the density increases that underpin artificial intelligence processors and advanced mobile hardware. ASML is the only company on Earth capable of building this machine. The $400 million price is not for its size or power consumption. It is for a precision so extreme that the technology required to achieve it did not exist when the project began. Northrop Grumman B-2 Spirit. The B-2 Spirit has an adjusted cost of $4.17 billion per aircraft in 2024 values. Northrop Grumman constructed 21. The United States Air Force currently operates 19. The aircraft uses a flying wing configuration with no vertical stabilizers. Its shape, combined with radar-absorbent material coatings and curved engine intakes, gives the B-2 a radar cross-section roughly equivalent to a large bird. A fly-by-wire computer system makes continuous automated adjustments to keep it stable, compensating for an aerodynamic profile that would be uncontrollable manually. Maintenance runs at 120 hours of ground labor for every hour of flight. Each operational hour costs approximately $130,000. In 2008, a single B-2 crashed on takeoff from Guam after moisture contaminated its air data sensors. The loss exceeded $2 billion. With 19 airframes remaining, the destruction of any one of them is not a maintenance problem. It is a strategic one. Large Hadron Collider. The Large Hadron Collider sits in a circular tunnel, 26,659 meters in circumference, buried between 50 and 175 meters underground beneath the French-Swiss border. It cost $4.75 billion and involved over 10,000 scientists from 100 countries. Its function is to accelerate protons to 99.9999991% of the speed of light and collide them. To bend the particle beams around the ring, 1,232 superconducting dipole magnets are maintained at -271.3 degrees Celsius using liquid helium, colder than the average temperature of outer space. The collision points recreate conditions that existed microseconds after the origin of the universe. In 2012, the LHC confirmed the existence of the Higgs boson, the particle responsible for the mechanism by which all matter acquires mass. 9 days after first activation in 2008, a faulty electrical connection caused a helium leak that damaged 50 magnets and shut the machine down for over a year. James Webb Space Telescope. The James Webb Space Telescope cost $9.7 billion and took 24 years to complete, beginning as a project estimated at $1 billion, with a planned launch in 2007. The technologies it required did not exist when it was proposed. Its 6.5-meter mirror is composed of 18 hexagonal beryllium segments, coated in gold, 700 atoms thick, optimized for infrared wavelengths. A sunshield measuring 22 by 12 meters, with each of its 5 layers thinner than a human hair, blocks thermal radiation from the sun, Earth, and Moon simultaneously, keeping the instruments below -223 degrees Celsius. The telescope launched on Christmas Day, 2021, and spent the following month performing 344 sequential deployments in deep space, each a single point of failure for the entire mission. A torn sunshield or failed mirror latch would have ended the program with no possibility of repair. Every deployment succeeded. USS Gerald R. Ford. The USS Gerald R. Ford cost $12.9 billion to construct, with an additional $3.7 billion in research and development. It is 337 meters long, displaces 100,000 metric tons at full load, and is powered by 2 nuclear reactors generating 600 megawatts, 250% more electrical capacity than previous Nimitz-class carriers. That power supports the electromagnetic aircraft launch system, which replaces steam catapults with linear induction motors, and the advanced arresting gear, an electromechanical braking system handling a wider range of aircraft weights than its predecessors. Both systems experienced significant reliability failures during development, contributing to a final cost 23% above the original estimate. The ship carries over 75 aircraft and sustains 160 sorties per day. Its island superstructure sits further aft than on previous carriers, opening deck space and improving aircraft movement efficiency. The Ford-class architecture is designed from the outset to support directed energy weapons as they reach operational readiness. Prelude FLNG. Shell's Prelude Floating Liquefied Natural Gas Facility is the largest floating structure ever built. At 488 meters long and 74 meters wide, it displaces 600,000 metric tons fully loaded, 6 times the displacement of a Nimitz-class carrier. Total project cost reached between $17 and $24 billion. The facility extracts natural gas from wells 250 meters beneath the ocean floor, cools it to -162 degrees Celsius, reducing its volume by a factor of 600, and loads it onto tanker ships alongside. To achieve this cooling, the vessel draws 50 million liters of cold seawater through its intake systems every hour. A single 93-meter turret anchored to the seabed allows the entire structure to rotate with changing wind and current, always presenting its bow to incoming weather. The Prelude operates 475 kilometers off the coast of northwestern Australia in a cyclone zone and is designed to remain on station for 25 years without dry dock. It exists because the gas field beneath it is too remote for a pipeline, and building the most expensive floating object in human history was judged the more practical option. ITER. The ITER fusion reactor in Cataract, France, began as a $5 billion project and has reached an estimated cost of between $22 and $25 billion. 35 nations are contributing, with the European Union providing 45% of total costs. First plasma is now scheduled for 2033. The machine heats hydrogen isotopes to 150 million degrees Celsius until they form a plasma and fuse, releasing energy through the same process that powers stars. Because no material survives direct contact with plasma at that temperature, superconducting coils, cooled to -269 degrees Celsius, generate magnetic fields that confine it. The same structure contains temperatures hotter than the solar core and materials colder than deep space, separated by a magnetic boundary. The vacuum vessel alone weighs 8,000 metric tons. An 8-year schedule extension announced in 2024 was attributed to defective components and the tolerances required to assemble hardware manufactured across 35 countries with millimeter accuracy. A successful result would demonstrate 500 megawatts of output from a 50 megawatt input, providing the scientific basis for commercial fusion power fueled by isotopes extracted from seawater. International Space Station. The International Space Station is the most expensive object ever built, at approximately $150 billion across 26 years of construction and operation. It measures 109 meters across its solar array span, orbits at 400 kilometers altitude, and travels at 28,000 kilometers per hour, completing 16 orbits of the Earth every day. Construction involved 16 nations, dozens of rocket launches, and 218 spacewalks to assemble and maintain its structure in vacuum. Internal systems recycle water from the atmosphere and crew urine, convert carbon dioxide back into oxygen, and maintain pressure and temperature continuously. The microgravity environment enables research into combustion, fluid dynamics, and human physiological changes relevant to long-duration spaceflight that cannot be replicated on Earth. The station is scheduled for controlled deorbit in 2030, directed toward the southern Pacific Ocean. The $150 billion structure will burn during atmospheric reentry, with remaining mass impacting open water. It will leave behind 26 years of scientific data, the confirmed viability of long-term human habitation beyond Earth, and no physical trace.